Thank you very much, and good morning, everyone. Artificial intelligence is already transforming industrial companies. And on this presentation, we're going to cover some of the applications that we have come across, been involved with. And in the second part, we're going to show the technical implementation, how you can implement something like that. So firstly, about the company, Wapice. We have been around from '99, building industrial applications, information systems. We are based in Finland, 340 people, and our tech stack covers the whole range from the electronics design to the cloud. But today, the topic, the domain, is artificial intelligence and how we can build smarter systems by using this piece of technology. There are a lot of definitions about the artificial intelligence. What are the tools, what you can use, what is included, what is not included. On this semantics, I think our approach is very practical. So we see that there are a lot of new ways by utilizing this new technology to improve the operations, the operational efficiency, building smarter machines. And this is our very practical perspective. Of course, we need to acknowledge the history. And the one interesting piece of equipment is from year 81. This is the CRS Wizard, technical implementation of a neural network computer built in Brunel University by Igor Alexander and other fellows. And this is something, if you ever go to London Science Museum, I think the 5th floor somewhere, the mathematics department, you can see the implementation, the hardware, how you can utilize a neural network. You can have the video streaming analytics, and the use case, what they have here was, I think, to have video stream and recognize the lecture from the research assistant. But I think a lot of the things, what has hardwired here is very similar what we are doing still today. Later on, Miki will show you the version of 2018, how we're doing it. Okay, so these are the giant's shoulders where we are standing on. But we see the new possibilities in the industry to use real-time data sources like video, audio, which is not very typical. Also, the streaming sensor data coming from the devices. And from a technology perspective, the ones we've chosen here are the ones we have some experience, include the deep neural networks, constraint satisfaction problem, mathematical optimization, and the clustering in the field of machine learning. In practice, the domains for a typical industrial company include sales, interaction with the customer, the products, operations, the manufacturing, and thirdly, services. We're going to have some examples of each of them, and let's start from the first one, which is the sales. Sales configurators are tools which we use when we dream a new car and we go to the website and we want to build our car. But from industrial perspective, these are the tools which capture the best knowledge of the best salesperson, the product knowledge of the organization from manufacturing, and we give this information for the people who have less knowledge about the up-to-date knowledge about the products. So this is a traditional rule-based system, but now today what we can do also, we can analyze what the users are doing, what the customers are what kind of configurations they are working with, what our salespeople are working, what kind of orders we get in the production, and we can improve the process by analyzing this type of data. And this is very interesting stream. The second theme is smart connected products. Many machine building companies already have implementation of automation in the systems. But what is new, we can introduce analysis on the edge level. So basically that means that We can have a sensor analysis, situational awareness, what's going on, and we can make local decisions. On the higher level, we can connect to the cloud, and these machines can talk to their brothers and sisters, to the fleet, and they can discuss if something what they see is what the others have perceived as well, and make decisions related to services, for example. And I think we're going to have an example how to build in such application in a few moments. Operations. If we take the manufacturing, especially the product quality is an issue. We can use the technology, machine learning, the technology to detect, well, in this case, a product which has some failures. Somebody already had this for breakfast versus complete perfect product. And there are a lot of these kind of tasks in the operation, the manufacturing, what we can, which is covered by human, or which is done maybe not so perfectly. So there's a lot of opportunity on the operations side on this. But there are also other types of operations, not only manufacturing. We can think of things like electrical utilities. We work a lot of in this energy industry domain, and we can take things like consumption of electricity and build learning profiles close to real time, detect what type of consumptions we have for its clusters, and we can detect that, okay, who likes to go to sauna 8 o'clock on a Saturday, and who's a person just bought new heating equipment for the house, things like that. And this is the business benefit of this is then to improve the efficiency, the accuracy of the forecast, and perform better. So this is another type of operations. And of course, then the after-sales part, the services, smart services. When you have implemented smart machinery, you have a fleet of smart install-based, and you have a smart process for the sales, how to take the orders in the system. So we can see that already in the near future, already today, that machines will be ordering spare parts for themselves. And this is very interesting application powered by the artificial intelligence. So these are the domains. What we see probably is not complete. It's not something what could not be. But this is something that what we see, what are already today, so down-to-earth applications. And now, on this point, I would like to invite my good friend Miki to tell how you actually create such an application by utilizing the tools of 2018. So, Miki, please. Yes, please.
No, okay. All right. Thank you, Petri. All right. So let's continue. My name is Miki Shroff, and I'm now going to show you how to create an AI-powered application. How to create it in a rapid manner, easily, and in a way that you could also do it to boost your own AI application development. The application that you see here, it was developed, actually the screencast time was 49 minutes. So the actual application development time was about that. So it's not too complicated anymore to do these kind of AI things. So what we did was we connected our systems to an air conditioning unit, and what kind of AI we added there is that we added machine vision to detect how many people is visible at the room where the air conditioning is functioning, and in addition to that, we of course included temperature from the environment. Okay, here you see how this application actually works in practice. On the left side is the air conditioning unit control box. We detect the persons. And on the left top, you see that the power output is a little bit changed when more people appear on the screen. Okay, all the data is aggregated to the cloud. We are using IoT Ticket. It's actually our own product. It's a cloud-based, big data-enabled IoT platform. We can aggregate any kind of data. And when you get when you do the AI at the edge side, you kind of get the end result in the cloud system. So basically, the AI part becomes just another measurement point. It's no different from the temperature sensor, and that makes it interesting here. How we develop this system? It's built from 4 parts. The cognition part, which does the person detection, then the environment sensors. We connect to the environment sensors, or we add our own sensors. Depends what kind of building you have. Do you have a building automation system or whatever? Then the air conditioning controller. There we have 2 ways communication. We need to get the status, existing fan speeds, power output, and then we have the 2 ways so that we can control it. We can control the fan speed of the air conditioning unit. Just to mention a few words, this is just an example application that we came up just for this event. It could have been something else too, but we just wanted to show you something visual that is easy to show and show that AI, it is a mature technology and you can use it quite easily in your own systems. So how the cognition part is built? Basically what is interesting here that we can have the video data. Okay, we are using live video data, but of course it can be offline files, images, whatever, cameras, IP cameras, USB cameras, what you need. The important thing here is the detector part, which actually does the analysis. It analyzes the video and gives you as an output the list of detected objects and their coordinates. Then we send it forward to the cloud. A few words about the detector. We are using a deep neural network to do the detection. Basically nowadays that's the best way to do this kind of generic detection. In case you would want to detect something else than persons, you can do it quite easily. You can train the network to detect whatever kind of object you want to detect. Here, there are a couple of things to consider when you are selecting a detector. For example, what are your latency, accuracy, and cost requirements? They are kind of compromised with each other. If you want low latency, you might have to pay a little bit more for the hardware. Same is true for the accuracy. So it depends of your application. If you are building an autonomous vehicle, then of course you want the lowest latency and the best accuracy you can get. But for this kind of air conditioning system, it doesn't matter if the detection takes a little time, 1 or 2 seconds, no problem. And the accuracy, no big deal if there is some misclassification. What we are using is a good compromise between accuracy and latency. And you can actually see the demo at our lounge there in the corner. Please come and see the demo. Okay, a few words about the connectivity and how to connect the sensors. It's really important that it is easy to connect different kinds of sensors to your cloud. whatever you are doing. Now we are doing a simple application, but in some cases it can be more complex. Maybe you need OPC connection to connect to some other system. Maybe there are some manufacturers where you need to connect to get your data. There are many options. Or maybe you want to integrate to some other system, ERP or whatever. So basically, connectivity, you need it. It's good to have. All right. So and the step 3 is connecting the air conditioning to the cloud in a secure manner. We are now using two-way communication, so the actual air conditioning unit didn't have internet connectivity, so we need some kind of protocol converter to do that. So we use the gateway to do that, and just make sure it's secure. That's maybe the main point here. Okay, so this is how you do the application. Once you have the data, now you aggregate it to the cloud, and this is how we build it. 49 minutes. I give a name to the demo application. Okay, then I just start dragging and dropping different kind of widgets. This is actually a browser in full screen. Once I have the widgets, I connect different data points to the widgets. I give labels, what everything means. And actually this is happening live. I'm now in edit mode, and you can see that the data is already appearing. So it's kind of what you see is what you get. The end product will be similar. It needs no programming. You can connect your application logic using this kind of data flow editor. You have your control widgets. And in the data flow editor, you connect how you want to actually control the airflow in the air conditioning unit. It's really simple. It's visual. It's ready. 49 minutes. Doesn't take that long. At the end, we did some cleanup. Just if someone wants to continue with that project, it's easy to continue. All right, so that's the end result. There you can see it seems to be working. The blue dots is the amount of people, and the orange line is the fan speed, RPM, if I remember correctly. All right, so I will end with that. When you have the right tools, all you need is an idea. And when you have the idea, just start creating. And that's why we are here. We will help you with that. Come and see us at our lounge. Thank you.